Hi class, I wanted to do an example of how to find a partial fraction composition when you're given a rational expression like 12x plus 14 over 9x squared plus 24x plus 16. So remember that what we're trying to do here is rewrite this rational expression that's kind of complicated right now as a sum of more simplistic, more basic partial fractions. And so you're basically doing the opposite procedure of combining fractions with addition using a least common denominator, and instead you're breaking it apart into where it could have come from. So in order to do that, if you remember, the very first step was to factor your denominator. So when we do that here, notice that this is really 3x times 3x giving you 9x squared, and 4 times 4 giving you 16, and 3x times 4 when you FOIL gives you 12, and you double that, you get 24. This is what we call a perfect square trinomial. So this turns out to equal, this fraction equals 12x plus 14 over parenthesis 3x plus 4 times 3x plus 4, or you could say 3x plus 4 squared. And go ahead and verify that if you need to. Go ahead and multiply it by itself by FOILing, and it's true. Now once you factored, the next thing that we wanted to do was create a template of what partial fractions added together would actually produce this. And so we had a few different options that we learned about. So we write our equation. Okay. So the equation that we're going to write out here, by recognizing that this is a linear factor, x is raised to the first power, but it's repeated, meaning it's more than one appearance. It's appearing twice here. Repeated linear factor. Sometimes you have a mixture of different types of factors down there. Repeated linear factors. Remember how we dealt with those? That was when we would take the original 12x plus 14 over 3x plus 4 squared and set it equal to a sum of partial fractions where the first fraction has a denominator of the original factor without being repeated, just 3x plus 4. And because it's linear in nature, we just put a simple letter with no variable next to it, just the constant a, for example, as a placeholder that we'll solve for. Plus another partial fraction where now we work our way up to the number of repetitions there are. If it's just 2 repetitions, we just write 3x plus 4 squared. If it had been 3 repetitions, I would have had to do another partial fraction, working my way up 1 degree at a time. Again, since these are linear factors being repeated, we just use the simple letter b. Let me write that a little cleaner. Instead of like bx, for example, if it was a irreducible quadratic below. Okay, so once you know the pattern, the next thing we want to do is get rid of the denominators. In other words, from algebra, clear fractions by multiplying both sides by the LCD, the least common denominator. So this is where we clear fractions using the LCD as your magical bullet, if you will, that will kill all of your denominators. So if you take that LCD of 3x plus 4 squared and multiply all terms on both sides by that LCD, which is what we have right here, the denominator here would completely cancel, leaving us with the numerator 12x plus 14. And feel free to write it out if you need to. Write that LCD next to each of them and watch the cancellation take place. It's a lot of nice algebra there. On the other side of the equation, we have a times something remaining, because if you take 3x plus 4 and you notice that there's 3x plus 4 squared next to it in the numerator, one of those factors cancels, leaving you just one of them behind. So there's still a 3x plus 4 left behind next to a. But for b, on the other hand, what happens if I put the LCD here, 3x plus 4 squared? That's right, they cancel completely, so all you have is b. Now this is actually quite nice. Typically we have more work to do, but the next step that we normally take a look at is we form a system of equations after we FOIL or distribute, and then compare our coefficients of like terms on both sides of the equation. So what I want to do here is form a system by distribute, and sometimes it would be FOILing, but in this case it's just distribute and compare like terms. That will help us find our system, okay? So there's nothing really to do on the left side. We can just copy and paste 12x plus 14. But on the right side, I can distribute a times 3x plus 4, giving me 3ax plus 4a plus b. Now I know it's a little bit weird to have lots of letters next to each other, but a is a constant whereas x is a variable here. So when I say compare like terms, what I'm saying is take a look on the left side. The highest degree term is degree 1, that is 12x. So if I'm making my system here of linear equations, I would do so by first comparing the coefficients of the x terms. Why is that? Well, you're saying this side equals this side. So if 12x equals something with an x over here, that must mean that 12 equals the 3a, right? Because these are your like terms. So it must be the case that 12 must be the same as 3a. So I can actually set those coefficients equal to each other. 12 must equal 3a. Well, you kind of know what that means, right? Use a little bit of algebra here, divide both sides by 3. A is 4. So already I know that the numerator for this partial fraction should be a 4, but we can verify that. And we continue now with the other term, which is a 14, the constant term. So 14 on the left should equal the sum of the constants on the right. These are your constants, 4a and b. So 4a plus b, when you add them together, should produce the 14. Well, since we now know what a equals, a little bit of substitution allows us to finish this guy up and solve for b. So we would then have that 14 equals 4 copies of a, but a is really 4, plus b. In other words, 14 equals 16 plus b. So what must b be? No pun intended. 14 minus 16 is negative 2. So if b is negative 2, this makes sense. So now we found the other numerator of our partial fractions. And so you could check this, for example, by saying, okay, so we're saying that the original, our claim now, final claim, the answer, if you will, is that this entire rational expression could be rewritten as a sum of partial fractions, where we have, for one of them, a was 4 over the denominator 3x plus 4, and then b is negative 2, so rather than saying plus negative 2 on top, it looks tacky, so we just write the whole thing as negative, minus 2 over parenthesis 3x plus 4 squared. And one could check that by, again, using your algebra techniques of getting a common denominator and combining your numerators accordingly, and seeing if you do in fact get the same thing you started with. Why is this helpful again? When you get into calculus, one of the things that you will be doing is you will be integrating rational expressions. And integrating something this nasty, especially in calculus 2 and 3, is going to be very, very difficult. But if you could rewrite it using partial fraction decomposition as simple partial fractions like we found here that mean the same thing, then you could integrate here very easily and integrate here very easily. And so this skill is going to be critical to your success in calculus. You might have to brush up on it, but just remember, the idea is when I'm integrating a rational expression, ask yourself if it's possible to decompose it into a sum or difference of partial fractions. Well, I hope this video is helpful. If you have any questions, please don't hesitate to reach out to me. Otherwise, happy practicing, because remember, math is not a spectator sport. I'll see you next time.